Hi, everybody. Couple of announcements. Tomorrow afternoon, we're doing our final set of reports, and it will be in the fifth floor room that we were in a week ago, and it's at 5:30, right? So come at 5:30, and it'll be 5:30 to 7:30, and be sure to come so that those poor people who had to wait till the very end have a really good audience, okay? The other thing I think you probably all noticed, we have a final exam. Want to write this down? Monday, May 9th. And it's at 11:30. And we have 3 hours, but it won't take you 3 hours because it will be exactly the same format as the quizzes, except there'll be more of the questions, and they'll cover the whole course. It's not just the second half, they'll cover the whole course. And it won't take you long to do. Remember, the whole point of exams in this course is not to subject either you or us to a grueling experience, but to provide you with incentive to go back and read all the stuff, okay? Any questions about that? Yes.
I know you have a policy not letting us take our quizzes, but is there any way we could see them to
Oh yeah, sure, you can see them. And how should we do that? I can give them to you, GSI.
You can get them for the last stuff.
Yeah, come up afterwards, and I've got the notes. I need that one. I think it's in the back somewhere.
So why don't we make that a general announcement? So if you want to see your quizzes, we'll bring them to the session next week, the last discussion section. And that way, we can do it more next way.
This week.
Next week.
Next week.
Okay.
Next week's that week.
Okay, so we have a dead week. The last week is dead week, and let me just tell you what we're going to do about that. There will be a review session on Wednesday, and I think Ryan and David are doing that jointly. So it will be here if we get this room. Otherwise, we'll get it up on the fifth floor. But that will be your chance to come and ask questions about basically reviewing for the exam. It's not required. Nothing is required of you in dead week, but it's available as an option. Yeah.
Is the final going to be here?
Pardon?
Is the final going to be here?
The final, we think, will be here. If not, we'll put signs on the door, but I think it'll be here. Okay, there was another question? Yes.
So the review session's gonna be, is that Wednesday at 5?
It'll be Wednesday, a week from tomorrow, 5 o'clock, and probably here. Okay? Now, the other thing is that my understanding of Dead Week is that you are not required to attend any classes. I'm going to have lectures for you on Tuesday and Thursday, which I hope you'll come to just for interest, but you're not required to, and there will be nothing about them on the final. But in particular, please, if you possibly can, come to the one on Thursday. Come to the one on Tuesday too, but especially come to the one on Thursday, because it's the one that's going to tie everything up together. So I hope you'll find it interesting enough to come, even though you're not required to, and it won't be tested. Any more questions about that? Any of that stuff? We okay for logistics then?
So the lecture would be at the same time as the class on Thursday?
Yeah, the lecture, it will be just like, the lecture will be just like the last week of classes. The schedule will be just the same as all the other weeks. Okay? Pick up a thing from Josh in the back. Oh, that one. Okay, got one. All right. Any other things we should talk about before we dig into this last general topic? Okay, so there's so many things that we could talk about in human history, and what I've decided I want to do is to talk with you about the history of science. After all, this is a class in a science department, so we should get some science into it, and we can combine history and science by talking about the history of science. And I'm going to do that in 3 stages. So today I'm going to talk to you about science in antiquity and the Middle Ages, a very early science, how science got started. And then, and you don't have to look at it, you don't have to digest it all now, we'll get to it. So then on Thursday, we're going to talk about science in during what's called the scientific revolution, the time of Galileo and people like that. And then next Tuesday in the optional lecture, I'm going to talk with you about what has happened in science in the 20th century. And then, as I say, on Thursday, we're going to tie everything together in a way which I think you will find really, really interesting. You won't want to miss. So let's talk about science in antiquity in the Middle Ages. How did science get started? So let me just give you a sense of the three main points, if I can now remember them, which I'd like you to carry away from this. The first point has to do with how unlikely it is that we live in a world in which science plays an important role. And so we're going to talk in this class about how many times science almost didn't make it. So let me ask you if any of you know the name of a series of suspense films from back when I was a child that were called The Perils of Pauline. Have any of you heard the term The Perils of Pauline? You can kind of see who was around in those days. Okay, so Pauline was the heroine of this series. And this is one that all us little kids used to go to. This is, I barely remember when there wasn't any television, but when there wasn't much. All the little kids would go to the Saturday matinee. And you go in and you watch this show every week. And it was about Pauline, and she was always getting in the worst kind of trouble, and at the end of the Saturday matinee, she would end up tied to the railroad track while the villain was wringing his hands and the train was coming, and she's just about to get there, and it stops and says, be sure to come next Saturday, right? And so you get there the next Saturday, and somehow or other, Pauline would be saved at the beginning of the film, and all sorts of stuff would happen. And at the end of that week, she would be hanging from the cliff by this rope, and the rope was fraying, and there was, this great drop. Be sure to come next Saturday and find out. So that was the Perils of Pauline. And so science has kind of had a Perils of Pauline kind of history. It's just amazing that we have science today. So that's the first thing I want to tell you about. The second thing is I want to tell you about how science got from where we usually think of it starting, which is in Athens in maybe the 3rd or 4th century BC, how it got from there to Europe and then to North America. And it isn't the way you would have expected it to get there. It had a journey. Science in its role of Pauline had a very unusual journey to get from where it started to where it is now. And then finally, I want to talk to you about categories. Anybody interested in categories? Well, some people think that categories are real things, and some think that they're just names. Okay, are you confused? Good. I hope you'll stay to find out what that all means. So those are the three things: the Perils of Pauline, the unusual journey, and categories. Are they real or are they just names? So that's what we're going to talk about. And I think we can do it all off of this little sheet here. So let's start with a mind map. And we'll start off with the beginning of science, which is usually traced back to ancient Greece. Now, there will be people who say, well, but the Sumerians, they were looking and they had astronomy, and so did the Mayans, and that's perfectly defensible point of view. Most scientists today would say, well, science is a very particular thing in which we make hypotheses and then we test the hypothesis, and if it succeeds in if it survives that test, then it continues and gets elaborated, but you're always trying to show what's wrong with it. So there's a skeptical approach. So it's not just being interested in the stars or being interested in mountains or being interested in living organisms. It's a certain way of trying to learn more about these things in a reliable way. And a lot of it has to do with making predictions based on your ideas and then testing them, seeing if they're so or not. You can say, well, let's ask nature a question. That's a kind of a test. What happens if I let go of this? Okay, my prediction is that it's going to fall. You agree? You think so? Let's see what it did. That's important. But we could do that all day, and if even one time it went up to the ceiling, then you'd know there's something wrong with our understanding of gravity. And this is a sort of a trivial example because we're pretty sure that it's not going to go down to the floor, but there are lots of things in biology and geology and physics where you make a prediction and you don't know what the answer is going to be. It's either going to confirm your hypothesis, support it, or it's going to reject it. So that's what I'm thinking of here in terms of science. And I think most people would say that the trend, the track that led to that view of science began in ancient Greece. Think of how different this is from a religious point of view. Because in a religious point of view, you are asked to accept things on faith. And even if there's lots of evidence against what you are asked to believe, it's considered a virtue in religious circles to believe in it on a basis of faith. You know, that's a very, very widespread in this country at the present time. So sometimes these two viewpoints, either I will take it on the basis of evidence or I'll take it on the basis of faith. Sometimes those are given the shorthand names. They're referred to as Athens and Jerusalem. And the idea being that in ancient Greece, people were really trying to look at the evidence and see what the real answer was. And the other one, which is sort of associated with Jerusalem, would be taking things on faith. So those terms are used a lot. So why the difference? Why did you have different approaches in these two kinds of cultures? And I've sort of tried to summarize that here. In Athens, sure, they had a pantheon of gods, but the gods weren't really omnipotent. I mean, they could do sorts of things to make human lives better or worse, but they were human gods. And and the gods had their own failings. Jupiter was always out looking for his next affair, and they got jealous with each other. There were fights. It was kind of like life in a big dysfunctional family. And so that's the kind of gods that the Greeks were dealing with. These were not the omnipotent gods. And then they loved debate. The Greeks in ancient times, even now, seemed to just love to discuss and debate and argue about things. And so when somebody would have an idea, somebody else would have the opposite idea, and there would be an argument. So Plato had one idea, as we will see, about categories, and his student Aristotle had exactly the opposite view. And they argued about it as long as they were alive, and their successors have argued about it ever since. So things were open for debate in ancient Greece. And the third thing that may have contributed to it was that Greece was a complicated peninsula with all sorts of little peninsulas and little bays, and the Greeks were seafaring people, and so they traveled all over the Mediterranean, and they were in contact with other cultures, and they saw that there were lots of other ways of thinking about things. There were other languages in which you could express concepts in different ways. There were different beliefs, there were different religious systems, there were different languages, different everything. So they were very cosmopolitan in that sense. They knew there was more than one way of thinking about things. Okay, if you look at the ancient Hebrews, for which Jerusalem here is our code word, and saw what their system was, they didn't have this large dysfunctional family of gods who were kind of up against it with each other all the time. They had one omnipotent God who had to be feared because of being absolutely almighty, and didn't engage in the kind of shenanigans that the Greek gods did. Right? And then a second thing was that the way you learned truth in that society, and I realize that I'm making this oversimplifying, but it's to make the point. How did you find out what was true? A prophet told you. Okay? And a prophet does not say, well, I think that this might be the case, and let's do an experiment and find out. That's not the way a prophet works. A prophet tells you because God has spoken directly to the prophet. And so it's a different way of finding out what the truth is. And then finally, the Hebrews were not cosmopolitan. They were a tribe that they wandered for a long time in the Sinai Peninsula, and they were not in contact with lots and lots of other cultures that were far away. So they probably weren't aware of the great variety of human cultures and languages and traditions and religions that the Greeks were. So at any rate, these are, Athens and Jerusalem are good code words for these two ways of viewing the world that we live in, and that difference continues to this very day. And you can just see it all around you in our own country right now. Okay, so let's go and look at the way things started out with science in ancient Greece, and be sure to ask questions as we're going along. This will be more fun if it turns into a discussion. We want to be Greeks rather than me being the prophet. All right, so let's talk about this thing called categories. And categories was a concept that was very, very important in ancient Greek thinking. And nowadays, people don't talk about it very much. How many of you have even heard about categories, Platonic categories? Okay, not very many, just a few. But it was extremely important in antiquity. It was important in the Middle Ages. Nowadays, it seems not to be important, but I think that's just because we treat that same debate with different words. And I'm going to come back to that to the end and show how we deal with it. So here's the story. So Plato thought that there were what he called categories, and he considered these to be absolutely real, in the sense that he would think about, let's say, justice or democracy or freedom or something like that. And for Plato, each of these was something that actually existed somehow in the universe. There was an ideal justice. And so sometimes that is called realism, because his ideas were that, his notion was that categories were real. Sometimes they're called ideas. So it's also called idealism, in the sense that ideals were real. Although later, philosophers have used those terms in a lot of different ways. But at any rate, the main point is that for Plato, these concepts were something real that existed, and his job, our job as scholars and philosophers and thinkers and scientists, is to find out what that real category is. And the example that's usually used, and I think it's a foolish example, but people will say, here's a chair, okay? Now, this chair is a moderately good chair. It's not a perfect chair. It's not an ideal chair. But it is the best that the designer could do at imitating the ideal, true, real chair which exists someplace in the sky and which we're trying to figure out. And so it's a little silly with a chair, but it's not so silly if you think about it in terms of concepts like justice. You were going to ask something, Dara.
Well, does he regard concepts like justice or freedom or any of these things as like a living entity? Did it have a force, a living force to it, or was it just the best of that,
Well, I'm not sure, and I'm not a philosopher, but I think the way to think of it is that there is an ideal justice, and if we could only figure out what it was, we could organize our society so as to honor that. Okay? All right. So that was Plato. Have any of you read Plato's Republic or browsed around in it? 1, 2. Okay, phew, great. That's great. Okay, so what Plato was doing in the Republic was he was figuring out what the ideal society would be and how you get there. And so this is going to be important as we come along. The idea behind his Republic was that you would start out with all the children, and all the children would get a little bit of education, and then you kind of pick out the best, I don't know, 10% or something like this, the sharpest 10%. And then you take them on to the next grade, and all the rest go out and work in the field or whatever. You know? And then those ones who did really well, they go on to study more. You know? And every time you come to an end of a section, a time interval, an age interval, you kind of select the smartest ones who learn the most, and they get to go on. Everybody else gets to go off and do some other job. And you keep narrowing it down, until you end up with these extremely educated philosophers who are now beginning to get close to knowing what the ideal of justice and truth are, right? And when you get to the very last step, then that last 10 or so select the wisest of the whole lot of them to be the philosopher king. Okay? That sound good to you? You know, as academics, it sounds pretty good to us, doesn't it? And as students in a really top university, you've made it through most of the stages, right? And so I remember when I was learning about this in a philosophy class, I said, you know, that sounds pretty good to me. And I said, has it ever been tried? My teacher said, nah, it's just an idea. I'm pretty sure he was wrong. And later on, as we go on today, I'm going to tell you about how it got tried and how well it worked. Okay, so that's Plato. Now, he had this student. If I had a student like this, I'd be really aggravated. Take note. Because Aristotle said, that's all just complete baloney. There aren't any ideal anythings out there. Certainly no ideal chairs, no ideal justice, no ideal anything. Those things are just names we give to some concept that we made up. Does that sound reasonable to you? And so Aristotle thought that categories were names, and so that is sometimes called nominalism. Nominal as in name. So you see there's some arrows that go there to different places, and the ones that come off of Plato are labeled realism, and the ones that come off of Aristotle are called nominalism. And it seems to me that the conflict between those two views, realism or nominalism, ran all the way through antiquity, it ran all the way through Middle Ages, and then we kind of lose track of it with the scientific revolution in the 17th century. But what I want to show you is I think the conflict still goes on. It's just that we don't recognize it as the same dispute. Aristotle also it's worth pointing out that Aristotle's physics was almost entirely wrong, and that the correct physics wasn't figured out until the time of Galileo, so a long, long time later. But at any rate, these guys are now in Athens, and they're sort of in the 4th century BC, and they're kind of duking it out over this difference of ideas. And you would then think that would be pretty easy, you know, to get from there to where science is now, because science for us, modern science, is basically a European invention, and we are kind of an outpost of Europe in the intellectual sense here. So we have science because we got it from the Europeans, modern science. So how did they get it from the Greeks? Well, you look at a map over there, you know, and it's not very far from Greece. I mean, you can get on a train and go up from Greece to Europe. It doesn't take all that long. So you'd think you would have started out by heading northwest from Greece, the concepts. That's what you would think. Turns out that's not the case at all. It didn't start that way at all. It started by heading east. Science did. So let's look in the upper right-hand corner at Alexander the Great. and the eastward spread of, here you can make a correction because that didn't print. Instead of Hellenic, that should say Hellenistic science. So Hellenistic means the culture that came from Greece and was spread by Alexander the Great. So look at that map. Greece is in the very northwest corner of that map, and the gray area is the area that was conquered by Alexander the Great. So it includes Turkey, Iraq, Iran, Afghanistan, Pakistan, down into Egypt in the southwest, into India even. This guy was an incredible conqueror, and although it doesn't seem to have been his intent to spread Greek culture, I think he probably just wanted to conquer a big area. He was very successful at it. And as a result, over the next 1,000 years, Greek culture came to dominate that huge area that you see from Greece all the way to India. I think in India, his soldiers finally got tired of this and they mutinied because they wanted to go home. And so that's where it ended. And shortly afterwards, Alexander died from drinking too much, which was one of his problems. And this empire, this huge empire, was split up among 4 of his generals, whose descendants then each built kingdoms in different parts of it. But just look at that now, and if you want to circle that word eastward, it's up at the top. Here's a first really important point about the journey of science. It didn't start by heading towards Europe. It started by heading away from Europe. So in those Hellenistic kingdoms that succeeded the empire of Alexander, science was very important. Greek science was spread all over that part of the world. Do you know where the most important place was? What was the most important of all of the places in the Greek world for science? Baghdad comes later. Baghdad's important, but it comes later. Alexandria. And then you should say which one, because Alexander named a number of cities after himself. But it's the one in Egypt. And I've got a dashed line going in there. It's on the coast of the Nile Delta, so it's on the Mediterranean coast. And so at that time, which is 300 and something BC, or 320 something, I guess, Alexander conquered Egypt, and the native Egyptian pharaohs, the whole line of pharaohs that goes all the way back to 3000 BC, if you remember, that is then replaced by a Greek ruling dynasty who are called the Ptolemies, Ptolemy, Ptolemies. And Athens continued to be the center for philosophy, but Alexandria really became the center of Greek science. There was an incredible library in Alexandria, the famous Library of Alexandria. And it was supposed to have been the most abundantly endowed with scrolls of any library in the ancient world. Would that we still had those scrolls, because so much of ancient culture that has been lost would not have been lost if we still had the Library of Alexandria. But in addition to being a library, we would think of it today probably as a great university, a great research center. And so some of the greatest of Greek scientists operated out of Alexandria. And almost the last of them, one of the greatest and almost the last, was Claudius Ptolemy. And there's that name for the kings, the pharaohs, the Ptolemies. It appears that probably Claudius Ptolemy was not a member of the ruling family, but just had that name. But he sort of represented the culmination, and maybe the culmination because it was the end of Greek science. And he's responsible for 2 great books which continued to be of fundamental importance for 1,000 years, more than 1,000 years. And the reason they continued to be so important was because he was kind of the end of the line. As you'll see in a moment, things broke down and Greek science kind of faded out. But these 2 great books remained. And the first one was called the geography. So what would you imagine that Ptolemy's geography would be like as a book? Oh, think about a geography book that we look at today. You know, it would have maps of different places, and it would have pictures of what the rivers look like, and the landscape, and the agriculture, and the people who live different places. It would be descriptive, right? Not this geography book. This geography book, I went and took it out of the library one time. It doesn't look like that at all. It's a long, long, long table of numbers. And basically the table has the names of places, cities or bays or harbors or mountains in the ancient world, and then it's got a latitude and a longitude. So this was the first guy to figure out that it was really valuable to know where in latitude and longitude each of these places was. And so, in a sense, it is it's a digital list of, what do we call it today? Not a digital elevation model. It's some other word for a long list that gives places and their latitudes and longitudes. And so I found this absolutely fascinating. So here's a guy who is doing something that's utterly modern. This is doing something that's late 20th century or 21st century, writing down this list. Now, how did he find these places? How did he find where they were? Well, it was hard because, you know, you didn't have Google Earth and you didn't have satellites up there photographing things. And so apparently what he would do was whenever a ship came into the harbor at Alexandria, he would interview the captain and say, well, where did you go, and how long did it take to get from here to there? You could get latitude pretty well, because latitude you get just from the angle to the pole star. Longitude is much harder to get, and so the captain presumably would say, well, we sailed 4 days west from the harbor of Halicarnassus, and we got to such and such a place, and then they'd figure out, well, that probably meant about so far. So if you look at the maps that are based on this, it's really interesting, because the latitudes of most of the places are not too bad, but the longitudes are really screwy, because particularly maybe the captain wasn't going to tell them the truth, because the captain had his own route that he wanted to keep using. But it was this attempt to figure out where everything was on the earth numerically. And presumably there were maps that were made from this, but all the ancient maps were lost. Fortunately, the list of latitudes and longitudes were preserved, and so in the Middle Ages, when Europeans got a hold of this list, they started making their own maps. So you can find now maps that were made in the late Middle Ages, say before Columbus and the Portuguese explorers. And they're based on Ptolemy's list of latitudes and longitudes, and it's really easy on that to see that longitude is badly distorted, latitude's pretty good, but it's absolutely fascinating to see. Nobody did better than that for a very long time. Okay? The other thing is his other book had to do with astronomy. And it's known by the name the Almagest. Almagest is Arabic for the greatest, or the great, as in the great book. And I'm not going to take the time to go through it. I've got a diagram there that shows planets and epicycles and deference. You notice that the Earth is at the center of the planetary tracks, because it wasn't until later that people were convincingly showed that it's the sun that's at the center of the solar system and the planets go around it. But Ptolemy had a very complicated way of accounting for the motions of the planets in the sky. And there are those things called epicycles. And I won't take time to go into that because it will distract us. But just as Ptolemy's geography was the great book of where things were on the earth, this was the great book of where things were in the sky and how they moved, particularly how the planets moved. And again, that was the state of the art for more than 1,000 years. I shouldn't say it's the state of the art, because particularly Arab astronomers improved on it. never quite made the critical change, which was to place the sun in the center. But they improved on it. What does improved mean? What you would like out of a table of positions of the stars, and the sun, and the planets is you'd like to be able to predict things like eclipses. Remember, we go back to science is something where you have a hypothesis and then you make predictions and you see whether your predictions are right. So you know there are going to be eclipses every now and then because there are, and what you'd like to do in astronomy, in this kind of astronomy, is to predict when the eclipse is going to be. And you know, now we do it perfectly. When there's going to be an eclipse, they tell you exactly where it's going to be into the second, when it's going to start, and exactly where you see it best from, and they always get it right. There aren't any mistakes, so we know how to do it now. Ptolemy's method, yeah, reasonable good idea, as long as you didn't go too far into the future. So you might be able to predict the next couple of eclipses reasonably well. But if you went to the eclipses that were 10 years or 50 years down the road, it would get worse and worse and worse. So what the Arab astronomers did was to make improvements to Ptolemy's system, which let you predict the eclipses better, but they could never predict them exactly right. So anyhow, that is now the height of Greek science in Alexandria in the 2nd century BC. And things now start to change within 100 years or 200 years. This is pretty well done in. There's virtually no science left in Alexandria. Why? Well, it was replaced by Christianity. And the early Christians didn't have any use for this kind of stuff. They were interested in salvation. They were interested in the second coming of Jesus. They were interested in interpreting Scripture. And it was just a completely different way of trying to find out what the world was like. And so the great library of Alexandria gradually fell into ruin. And the Greeks stopped arguing about nature, and they started arguing about things like the nature, the physical nature of Christ. And so I've got that in the lower corner here. I've got the picture of the Santa Sophia Cathedral in Constantinople as a symbol of Byzantine Christianity. And there were, throughout this time interval, and now we're talking from maybe 300 A.D., which is Constantine, on for the next 1,000 years or so, there were these great theological disputes in Byzantium, but they were disputes about what does the Bible mean, how do you interpret it, what was the nature of Christ, what is the nature of this, that, and the other thing. And they were happy to argue about that, but the one thing they wouldn't tolerate is people who were trying to find out about nature by doing experiments. And so Greek science just basically died out. And that's the first of the perils of Pauline. And how did, okay, if you come back the next Saturday to the next matinee, how did Science Pauline escape that peril? Anybody know? So we still have science. Mm-hmm.
Well, within the church, weren't there priests amongst themselves who pursued these?
Not then. Much later there were. Okay. Josh.
Well, the Crusades put them back in touch with those parts of the world, right?
That's right.
That would-
So there was still something in that part of the world, and that's the question. People?
How about the Copernicus revolution?
Well, we're talking about science that died out in early Christianity, which basically means 4th century AD. And Copernicus is 16th or 17th century AD. So there's a 1,000-year gap in there, which somehow science survived. Yuli?
Guess maybe math.
Pardon?
Math.
Math?
Through mathematics, like better.
Well, you know, in a sense, but it wasn't happening in the Byzantine church.
Did they uncover like ancient manuscripts? They like found-
Much later. Yeah. Deborah?
Other people are looking at,
Okay, and
science.
who were the other people? Come on, you guys need
Arabs.
to know this in this world that we live in. Muslims, absolutely. Science was saved by Islam. That's really important to know. And so, when did Islam break loose?
6th to 7th century.
7th century. So, I'm getting it right. Yeah. The number I keep in mind is 632, which is I think the death of Muhammad. And at that point, Muslim armies, who, you know, the Muslims were really energized by the Prophet, and they broke out of the Arabian Peninsula in this incredible series of conquests. And so what Alexander had done for Greece in like 300 and something BC, the Arab armies did for Islam about 1,000 years later. And now if you look down in the lower center part under number 4 there, you'll see the area that was conquered by Islam, and it's huge. It's bigger than what Alexander covered, and it all happened in about 100 years. It was just incredible.
Can I just go back to like the Byzantine time?
Yes, please.
Why exactly was the Christian church so threatened by science, even science that might not directly contradict biblical teachings?
Oh boy, has anybody got a good answer for that? They definitely were. I think it was that the Bible was considered to be the source of all truth and all wisdom. You didn't want people out there holding it up to scrutiny.
So was it kind of like a power thing? Like the people that were in charge were the ones that were behind the Bible, and they felt that they had to be completely right. If they were ever proved wrong by any kind of scientific advance, then they felt like they would lose their own power.
I suppose that might be one way of looking at it. Maybe another way would be to say that if you are utterly convinced by whatever religious views you hold, then you know that the other stuff is wrong. I mean, it isn't that you think it's wrong, you know. And so, get rid of it. And, I've never really quite thought of that question exactly that way, so I'm not answering that very well. Yoes?
I think also there's the idea that if you're looking at the world, you're looking in the wrong place. The world is the place of like sin and deceit,
Mm-hmm.
and so you might learn something about the world, but it's not the right kind of knowledge to have.
That's absolutely right. And that view of the earth as a sort of a cesspool of corruption doesn't really disappear until the time of Galileo. So people had their eyes focused not on this world, the religious people had their eyes not focused on this world, but on the next world that they were trying to get to. And that was going to be the good world. And this was the evil, corrupt world. So why would you want to study that? So, if you find yourself interested by these, this line of thinking about history, and you start reading about it, it's absolutely fascinating. You discover that people then thought utterly differently about it than the way many people do today. Deborah?
Plus, if you think about what the population was like and how few people were educated, how could you reach people that were uneducated with notions that required information, where everybody could have the imagination and the dream of a better place? You know?
Well, I think it would be probably fair to say that this sort of discourse was always the realm of educated people. So that in ancient Greece, this wasn't a slave out in the street who was talking about this stuff. This was people who were wealthy enough to have leisure time to think about it. So it was probably always an elite occupation to think about these things. It's just that before Christianity in Greece, the elite thought about questions of nature and philosophy, and after that came to an end, they thought about questions of theology. And I hope you understand I'm trying very hard not to be judgmental. I'm trying to be as neutral as I can about this and give it a historian's view of things. Okay, I should point out, I just skipped over, if you see where it says 3 in a big black box, underneath that is a picture of a Roman aqueduct. And I neglected to point out that Rome was not part of the solution even before Christianity, because the Romans seemed to be less interested in philosophy and science than the Greeks were. The Romans were master engineers and master legal people. I mean, Roman law was one of their fundamental achievements. But natural science really just wasn't. And so they weren't so interested in it. But when the Muslim armies conquered basically what Alexander had conquered 1,000 years before, and as you see in this map, extended westward through North Africa and all the way into Spain and conquered almost all of Spain, they seemed to be absolutely fascinated by the cultures that they were in a position to be the rulers over. And so that with great interest, they collected all of the Greek works that they could find, the ones that had survived the antipathy of the Christians, and translated them into Arabic. So remember what the name of Ptolemy's astronomy book was? I mentioned that it was called the Almagest, which means the great, parentheses, book. And that's an Arabic word. Yeah. Remember, anything starts with A-L is likely to be an Arabic word. And so we have that book because it was preserved by Islam, by Islamic scholars and scientists for, 1,000 years, when people in the West weren't interested, and people in Greece weren't interested because they were focusing on theological questions rather than natural history questions. And so through all of that time then, from the Islamic conquest, let's say in the 7th century and the 8th century on for probably until maybe 1200 or something like that, the Islamic scholars and scientists built on the Greek basis of what they had found. And so there are great Islamic philosophers of the time. Avicenna is one. Alvarez, you probably maybe heard those names. They were either usually in Persia or in Spain. Somebody asked about where? Baghdad. Okay. Who asked about Baghdad? Somebody. Okay, Andrew. So Baghdad then was one of the two greatest centers of Islamic culture and Islamic science. It was Baghdad in Iraq and Cordoba in Spain were the great centers. And if you had wanted to be a scientist and you lived in those days, just as today you'd like to be at Berkeley or Cambridge, Massachusetts, or one of the great centers, in those days you would have wanted to be in Cordoba or Baghdad, because that's where the great advances were made, and we owe so much to those people. Okay, so that was the salvation of Pauline from the great peril of Christianity. All right, so the other thing about this, if you notice in the bottom center, is that the Islamic conquest brought science back westward. Remember, through Alexander, it had headed off to the east in a direction opposite to the way it ended up for the science we know. So it was the Arabs, the Muslims, who began to bring science back westward and into Spain. All right, ready for the next peril? Okay, so somewhere around 1100, 1200, something like that. The approach in Islam changed, and it started to become very much fundamentalist. And in the same way that Christians, 1,000 years earlier, had disparaged and discouraged science because they were interested in a very fundamentalist view of religion, that began to happen in Islam as well. And the last really great Muslim scientists were probably in the 1100s, maybe the 1200s, something like that. Yeah, Matt?
When you say fundamentalist, what exactly do you mean?
I'm sure that's a loaded term. So what I'm thinking of in this case is people whose worldview is entirely centered on Scripture and interpretation of Scripture, as opposed to any sort of experimental or philosophical approach to things. Okay? So if that had gone on and nothing else had happened, it's very possible that science would have died out within Islam. So that's peril number 2, and now we've gotten to the end of the next Saturday's matinee, and science is about to die out. And what happened? What was the saving of science in this particular case? And it came just barely in time. Well, Christianity to the rescue. So things changed, they reversed. And so now in the Christian church, somebody asked here earlier, what about Christian monks and scholars who were interested in these things? This starts to happen now. In the Christian world, starting around 1000, something like that, 1000 AD, 1100 AD, something like that. And now there start to be people in Europe with enough education, and these are almost entirely churchmen. Yeah, Andrew?
I was going to comment that I forget which pope it was, but there was actually one of the popes around, I want to say like 1000, lived in Muslim Spain. He studied there, and that was like
absolutely right. And who was that?
I forget his name.
You're absolutely right.
But that would be
he'd been one of the people I'm just about to tell you about. So in those days, if you were in Christian Europe and you had intellectual interest, well, you wouldn't go talk to a guy in the next room in the monastery because he didn't know any more than you did. You'd want to go to talk to people who really knew a lot about it. And it became clear to these Christian intellectuals that the Muslim world, even though in the Christian view the Muslim world had absolutely the wrong view of everything, and probably those people were all damned, but nevertheless it was clear that they knew a lot about philosophy and science. And if you wanted to find out about intellectual matters, you better find out from Muslims because they knew more. And so that Pope, whose name was Gerard of something, I'm trying to think who it was. Anyhow, he was one of the early Christian intellectuals from Western Europe who went to Spain. And in Spain, not only did you have access to all of the writing of the Islamic scholars and philosophers over nearly 1,000 years, half a thousand years, you also had access to the work of the Greeks. You could read Aristotle. You couldn't read it in Greek because that was all lost. But you could read it in Arabic because it had been translated into Arabic. It had never been translated into Latin. The church didn't have any use for Aristotle. The early Christian church didn't. So Aristotle never got translated into Latin. So you'd have to learn Arabic and go to Spain, where you could read these wonderful books. It turns out that Plato had been translated into Latin, and Plato was available to these Christian monastic scholars, and for a very interesting reason. Why did the church like Plato? remember Plato's Republic? What was it? You start with all the children, and then the best ones go to the next grade, and the best ones go to the next grade, the best ones go to the next grade, and then finally the top few choose the best among them to be the philosopher king. That sound anything like you? Like anything to you? Does that sound maybe like the College of Cardinals electing the next pope? Well, it is. So it turns out that, in my understanding, which, I'm not a specialist in this field, but I'm interested in it, my understanding is that the Catholic Church was organized on the lines of Plato's Republic. And not only that, but remember, Plato thought that there was a great chair and a great justice in the sky, and the job of the intellectuals was to make our justice on earth and our chairs on earth just as close to that as we could by figuring it out. Think about that. For medieval Christian churchmen, the church on earth, the church, all the believers, was the best they could do at imitating what they figured was the celestial church in the sky, which was the real church. And they were trying to get closer and closer. So you see, Plato's views absolutely accorded with what the church was like. Maybe partly because it just was a good match, and also basically because the Christian leaders had all read Plato and they were modeling things on that. So Plato was just right for the church, and Aristotle was not. Aristotle was interested in evidence, and that's the wrong thing. So Aristotle was forgotten. So if you were our pope that we're trying to remember the name of, and you wanted to find out about Greek philosophy, you go to Spain. Read Aristotle in translation into Arabic, and see these guys now we're talking about 1100s, the 12th century. They were aware that Aristotle existed, and they had gotten to the point where they wanted to find out what this was. So the whole view changed. And so now I've got a picture down in the lower left, and that shows how ancient knowledge, Greek knowledge, and particularly Plato, but all the others like Ptolemy and his Almagest and his geography, how those got into Western Europe. It was by way of translators, and these were guys who wanted to find out about these books, and so they would go. A few went to Palermo. Most of the medical works were translated in Palermo in Sicily. The philosophical and scientific things were almost all translated in Toledo, and that was because by the time we're talking about, Toledo had been captured by the Christian Spanish. We talked about this earlier on. That was 1077. Is that right? No. 1085. Excuse me, I have the wrong number. 1085. By 1085, Toledo was in the hands of the Castilian kings, the Christian kings of Spain, who therefore had the keys to the libraries. The great libraries of Toledo accumulated when it had been the capital of a small Muslim kingdom. And so within the libraries of Toledo, you had all the books. And so the translators were these various people that came from, there was one from, a famous one from Italy, one from France, one from England, from these various different places. And these guys would go down to Toledo and basically working with Arabic-speaking scholars who in many cases were Jews. They translated from all these great things from Arabic into Latin, and then these things, now they're diffused into Europe, and they're in the center of what Christians are now learning. So that's the solution to the second peril of Pauline. That's how science got saved from disappearing within the Muslim world and got back into Christianity. I think the translators it must have been a fascinating time. It took about 100 years to translate all of those books and for them to be digested by Christian scholars. before the Christian scholars could start making new advances. And I think there's a perfect analogy to that. Any of you aware of SETI? S-E-T-I, you know about SETI? The Search for Extraterrestrial Intelligence? Okay, so we actually have up here at the Space Sciences Lab, there's a SETI group. And so these are the people who are out there with radio telescopes like Carl Sagan, and they're listening to the night sky, and they're hoping that they will sometime be in contact with a greater and more advanced civilization somewhere on a star that's not too far away. And so Carl Sagan, who really started this idea, wrote a novel called Contact. Any of you read that? Contact. Okay, good. So Contact is about a young woman who's in this imaginary SETI thing, and she's modeled after a woman who's up here, the character. What's her name?
Jill Tarter.
What?
Jill Tarter.
Jill Tarter, exactly. So Jill Tarter is a leader of the SETI effort, and she was really the model for Carl Sagan's character in Contact. And so what happens then is, in the novel at any rate, basically the great knowledge of much more advanced civilizations than ours is funneled through radio communications, and suddenly, instead of knowing what we know now, suddenly we know what a civilization that's been doing science for thousands of years longer than us knows. Don't you think that's what it must have been like for the translators? Here they are coming out of intellectually impoverished Europe, and they're going down there and they're sitting in these libraries in Toledo, and laid out before them is this great treasure of knowledge of the Arab world, of the Greek world, going back even there was stuff from the Sumerians that had come through Greeks. All this treasure was suddenly took them 100 years. First of all, to translate, and then to digest this information, and then to do something with it. So there's this long gap between the beginning of the translation and when Western science takes off. And that's the century it took to digest all this stuff. So I personally would be really disappointed if we were ever able to read the Encyclopedia Galactica through the efforts of SETI. Because that would mean, supposing it happened today, all right, I've had fun at doing science, but you guys wouldn't get to. You'd have to spend the next century, you and your descendants would spend the next century digesting what some advanced civilization had learned. And it would take you a century, or I don't know, much more than that, to digest it and make sense out of it. I wouldn't want to do that. I think it's much more fun to learn it on your own. But anyhow, that's my image of what it must have been like to be in the movement of the translators in Toledo. Okay, so now we are up to about 1200 and something, 1300, something like that. And we've gotten science all the way around, from Greece, around through Alexander's empire, then back through the Arab world, back into Spain, and now it has diffused up and it's available in Europe. So that's this long, circuitous route that science took to get here. And you would think things would have taken off, but there was one more bad time to go, and that was the 14th century. Have any of you read, Barbara Tuchman had a book that's called The Distant Mirror, and the subtitle is something like The Catastrophic 14th Century, something like that. This was a terrible time in Europe. This was, remember what happened in 1349? Anybody know what happened? Pardon? Plague, yeah. This was a time of bubonic plague. It was time of terrible wars. It was time of economic collapse. It was just a really, really bad time. So then we come out of things, and we're now finding after that, and we're approaching the scientific revolution, which is going to be the topic of Thursday's talk. But I just want to show some of the things that went into that and sort of tie some loose ends up together. So the scientific revolution was a time in which Europeans finally got back to what the Greeks were doing, and that is understanding the world we live in on the basis of experiment and observation and evidence. And testing theories and get rid of the ones that aren't right. And there were quite a few interesting things that went into that. So intellectuals in the Middle Ages didn't like to get their hands dirty, or in Greece either, you know. God, dirty fingernails, how unprofessorial that would be. And so it turns out that technology really didn't come from intellectuals, it came from working people, you know. So I've got a picture of a windmill from Holland there. And so there were millers who were learning how to use the energy of flowing rivers or blowing winds and turn that into energy that can be used to do things like grinding grain. Otherwise, you know, either your wife or your donkey had to walk around in a circle all day turning the millstone to grind up the grain. Now it could be done by wind or water. And wind was also great for transportation because the sailing ships that were developed, remember we talked about the Portuguese ships, and you know that was using wind power to move things around. So a lot was done in the Middle Ages to learn how technically to do things. New plows were developed. All of these things that were ways of making better tools, better instruments, things like that. Okay, then there was the voyages of discovery. We've talked already about that. I'll belabor that point. But then some of the European scientists started to think that experiments were a good thing to do, and so I've got a picture there of Roger Bacon from the 13th century. He was an English Franciscan from Oxford, and he was one of the great early scientists. He was particularly interested in optics, so he dealt with lenses and what they do, how they make light change, and he was really one of the great leaders of that. And so he's in the 13th century, the 1200s. So things get bad then in the 14th century in the time of the plague, and then they eventually come back subsequently. But I want to bring full circle something that we started with, and again, this is not my field. I'm not an expert in it, but I'm very interested in it. I've read a lot, and so let me give you my thinking about this. So theology played a role, and in a very interesting way. So let's go back once more to ancient Greece and to the dispute between Plato, who thought that categories were real, and Aristotle, who said that categories were just names. Okay. Remember now that Plato's realism was just what they needed in the Catholic Church. I mean, that's how the hierarchy was structured, and the church on earth was the best image you could make of the true, real celestial church in the sky. And so most of the earlier Christian thinkers had been Platonists, or Neoplatonists, they call it. They thought in the terms that Plato used. And so as we get on toward the scientific revolution, or in this case even before, we're now talking 13th century or so, the conservative factions, the conservative intellectual factions within the Christian church were basically followers of Plato. All right, now, remember we've got these young Turks coming along, young intellectual young punks who want to go off and go to Toledo and find out what was in all of those books that they'd never been able to read because they didn't exist in translation. Now they're discovering Aristotle. Aristotle's got an utterly different way of thinking about things. So if you were on the cutting forefront now, in the 13th century, if you were one of the people like our Pope friend who went to Spain, you would start thinking, God, Aristotle, that's great. Let's forget about all that Plato. That was old hat. That's old conservative fogies think that. And so it seemed like Aristotle was the way into modern science, and in many ways, indeed was, because he was making observations and check. Think about the difference. For Plato, if you wanted to know what that true justice somewhere in the sky was, you would think about it. You would just think and think and think until your brain hurts, and then you'd talk it over with people, and then you'd think some more, and you're trying to be the philosopher king. Aristotle did it a completely different way. He wasn't interested in justice. He was interested in how things move, and so he would do experiments. And so that came into how people were learning to understand the world in, let's say, the 13th century. So Plato was old-fashioned. Aristotle was the new wave. And here comes to me, an absolutely delightful irony. Plato had a role to play, because surely Aristotelian experiment and observation are critical to science. What are we trying to do at the most fundamental level in science? We're trying to find out how the world works. We're trying to find out what nature's laws are. Do you remember I talked to you about my meta-scientific discoveries that I didn't make them, but I've thought about them? One of the meta-scientific discoveries, the beyond science, is the discovery that nature is orderly. Nature, everything follows natural laws. Think about it for a second. Think about a great law of nature, like relativity or quantum mechanics. Don't you think that is a true category in the sky in the Platonic sense? That if we understand relativity, or for Paul, if we understand the expansion of the universe or something, we're understanding something that is absolutely fundamental, and it's true in the sense of one of Plato's categories. I think it's that way. Okay, so here's what was happening in the 1200s. The people then who were getting used to thinking scientifically, they were after the age of translators, so they've got all this stuff in translation. They've got Plato, they've got Aristotle in translation. Many of the churchmen who were involved in this effort belonged to either of two religious orders that were founded early in the 1200s. What were those? Do you know what those are? Betty?
Jesuits.
Jesuits came later. The Jesuits is a good example, but they came later.
Monks?
Well, they were monks, and they were two kinds of monks. Two kinds of friars, actually. Okay. Lutherans later. Lutheran is in the Reformation. Okay, these are the Franciscans and the Dominicans. Okay, so the Franciscans were founded by Saint Francis of Assisi, who was an Italian, and the Dominicans were founded by Saint Dominic of, I forget what, from Spain. But in both cases, these were people who basically eschewed personal possessions, and they went out to preach to the people. And this is the most amazing irony here. So the Dominican order, for the most part, attracted really intelligent people who were willing to go out and have debates, theological debates, and convince people to come back to the church and this sort of stuff. St. Francis was absolutely not an intellectual. St. Francis was a very poor, humble guy who almost took pride in not being intellectual about things. So many of the Franciscans were simple people like Francis was. But Francis so attracted people by the strength of his personality that some intellectuals became Franciscans also. So on your book here, this guy just to the upper left of the center, Roger Bacon was a Franciscan and one of the most brilliant men of his time, but he was a Franciscan. Okay, think about this. This is where I just love this bit. So the Dominicans now, you have the most intelligent, brightest people of all. So of course they're in the vanguard of everything. Aristotle is the man, you know. Well, Aristotle did not lead to the deepest insights of science. On the other hand, you had the Franciscans, the followers of poor little Francis, some of whom were very intelligent but were still inspired by Francis. And Francis was conservative theologically, so he was attracted to Plato. And so when you read the history of science in the 13th century, the great discoveries were made by Franciscans, not by Dominicans. Were made by Roger Bacon and another Franciscan with a wonderful name for a scientist, William Grosseteste, which means William of the Big Head, and a number of others, William of Ockham. And these were guys who were still thinking Plato and looking for the great laws that lay behind everything. And so I hope you enjoy this extremely twisting, convoluted path by which science has come to be what it was. Maybe it's a good example of contingency in history. And that will be what we talk about on the very last day.